Hi everyone, welcome to our Pegasus online office hours. Today we'll be going over migrating your workflows to Pegasus 5.0. So you've installed Pegasus 5.0, what are your next steps? So existing workflows written in the DAX3 format, which is our older format, these need to be updated to use the new YAML format. Support for the older formats will end in Pegasus 5.1, which is going to be released in about 9 months from now, so early 2022. New workflows should be written using the new Python API. We do have a Java or R API, but we highly recommend using our Python API. Your submit node is going to need to have at least Python 3.5 and above, and you'll need to perform a simple database upgrade, and we have a command line tool for you to do that. It's really straightforward, and I'll go over that in a few slides. So first I want to go over an overview of changes that directly affect your workflow development. Now the first one is our file format changes. So in Pegasus 4.x, we had these file formats right here for our workflow, site catalog, transformation catalog, and replica catalog. These are now being moved over to YAML. Our default data staging configuration is now Condor.io. So prior to version 4.9, shared FS was the default data staging configuration, and so in Pegasus 5.0 and above, if you had used shared FS before, you need to explicitly set this in your properties file. And you can do this by saying pegasus.data.configuration space shared FS. By default, output files now have this register underscore replica equals true flag set. So when you use the API and you add an output file, this flag is set to true by default. So these files will be registered in your output replica catalog. The default site catalog, we create one if none is picked up by the planner, and it contains 2 sites, a local site and a Condor pool site. And so this is really convenient because if you're just running on a local Condor pool, you don't need to write out the whole XML file to generate this site. We can generate one for you. Next, as I mentioned, you do need to perform a database upgrade on the Pegasus master database, but it's really straightforward. All you need to do is run the command pegasus dbadmin update-a from your terminal, and that will update everything for you. And lastly, one of the biggest changes is that our Python API, which was formerly called pegasus.dax3, has been reworked from the ground up. So you can build a properties file and all of the catalogs programmatically. Overall, the API usage has been simplified, so things like adding inputs or outputs takes less lines of code, and just generating the workflow altogether is a little more intuitive. Also, you can plan, submit, analyze, and monitor directly from the workflow script. So in our Python API, we provide wrappers to all of the Pegasus command line tools that you're used to using. Next, I'll be going over the differences between a workflow script written for Pegasus 4.x and below, and a workflow script written using the new Python API and run with Pegasus 5.0. So starting with a Pegasus 4.x workflow script. This was typically a shell script that invokes Pegasus plan at the end. Catalogs are usually generated either in this shell script inline, or they might exist already on your file system. For the transformation catalog and replica catalog, you were able to embed these into the DAX with some limited functionality. So you could add files, you can add executables, but you couldn't add containers. So if you needed to use containers, then you'd have to use a text-based transformation catalog. The Pegasus RC, just like the catalogs, is also generated in the shell script inline, or you might already have one existing on the file system. And then lastly, you have a workflow generation script that's typically invoked from within this shell script to then generate some workflow.dax file. So in the end, when our workflow script runs, we end up generating these files right here. Some may be omitted. And then in the end, you just run them all through Pegasus plan, which takes your abstract workflow, looks at the catalogs, and then converts this workflow into an executable one, and possibly runs the workflow itself. So this is what that might have looked like. So this is our plan.sh script, our workflow script. So you might have some setup at the top. Here we're going to invoke a Java DAX generator, and so first we need to compile it, set our class paths. Then we invoke that Java DAX generator. So there's another file that this script is referring to, which you see on the right here to generate our workflow. After that, you're going to generate your catalogs. Here we're just generating the site catalog. You can also generate, your transformation catalog and replica catalog if they don't exist as separate files. And you can, create a Pegasus RC file as well for configuration settings. And then last, at the end, you would invoke Pegasus plan, and you would plan and then potentially run your workflow using all these files that you've generated. Now, when it comes to a Pegasus 5.0 workflow script, this can be a single script using the Pegasus 5 Python API. So you can programmatically generate all the catalogs and the properties files, as I've mentioned. Pegasus.properties is a new default name for the properties file. Site catalog is a default name of sites.yml. A default one will be used if none is picked up by Pegasus plan. So if you're running on a local Conjure pool, it's convenient to just use the default one, so you won't have to generate one for yourself. If you do generate one, it would overwrite the default one. The replica catalog can be generated as well. By default, this file that Pegasus plan looks for is replicas.yml, and then the transformation catalog, which by default the file is transformations.yml. Even though you can put everything and generate them from one script, these catalogs and this properties file, these still remain separate entities from the abstract workflow itself. And then lastly, you can plan and run directly from this Python script where you've generated everything. And so in the end, you still end up with this same workflow of generating all these files that you need, properties, catalogs, the abstract workflow, and then invoking Pegasus plan at the end. And so this is what this might look like. We have a script, workflow.py, where we generate our properties file. We generate our replica catalog, so we specify any of the inputs that are used by the workflow. We generate the transformation catalog, specify any executables that are used by our workflow, and then we build up the abstract workflow itself. And then lastly, you just call workflow.plan. And then your workflow is going to be planned and run, and we have some other helper functions that you can attach on to the workflow object to wait, monitor, analyze, call statistics, and so on. So next I want to go over how to migrate your Pegasus 4.x workflow scripts and each component in them to use a new Python API and to be run with Pegasus 5.0. So when you migrate these workflow scripts, you first need to migrate your catalogs from the 4.x format, which was XML or text-based, depending on the catalog, to be in YAML. And so there's two ways that you can do this. You can generate a new catalog using the Python API, which is what we recommend, or you can convert your existing catalogs in their XML or text-based formats over to YAML using one of our catalog converters. So we have a Pegasus SC converter, Pegasus TC converter, and a Pegasus RC converter. So we recommend generating new catalogs using the Python API because if you have to later on go in and make changes to your catalog, you would just make a change in your code that generates the catalog, and then the catalog will be written out correctly. Versus if you go in and you edit the underlying YAML file, you might make a change that doesn't adhere to the schemas that we use. Next, you'll need to migrate your workflow generation script from using pegasus.dax3 to using pegasus.api, which is just the name for our new API that we have. First, let's start with the site catalog. Here on the left, we have a file, sites.xml, which illustrates the older version of the site catalog. On the right, we have a script generate sc.py, which illustrates how you would generate the same site catalog, but using the latest Python API. In this catalog, we have 3 sites. Our execution environment has a site called local, Conjure pool, and a staging site. So starting with the local site, here we have this tag site, and then we have a handle that's the name of our site, and then we've specified that its architecture is x86-64 and its OS type is Linux. Then we've added these two directories for it, a shared scratch directory and a local storage directory, for which each one we've then added a file server to it, which says the type of operation that will be done and the file protocol that will be used to transfer files and retrieve files from those directories. So on the right here, we have created objects for each of these tags here. So starting with the site catalog object that represents our whole site catalog, then we create a site object that will represent our local site, and we pass in the same attributes that we have passed in here. So its handle is local, architecture is x86-64, OS type is Linux, and then for that site, we need to add these two directories, shared scratch and local storage. So we then create these directory objects, and the usage is very similar to what we have in the XML. So here this directory type is shared scratch. The path to it is going to be this path right here. Then we add a file server to it, which specifies the type of file operations that can be done there and the file protocol that will be used. And we do that again for a local storage directory. And once we've created those two directory objects, then we then add them to the local site. So in XML, you just have this nested structure, and we have these child objects here. So with the Python API, you would just create the objects and then add it to its parent object. So for the site object, you would add directories to it. And for the site catalog object, you would add sites to it. The next, we have the conjure pool site. So you create a site object in the same way that you did above. And here we want to add some job managers. So we create these grid objects, and then we add them to the conjure pool sites with this function add grids. So these grid tags or entries right here map pretty much the same when you use them in the Python API. For this conjure pool site, we have a shared scratch directory, so we need to add that as well. And then lastly, we add the staging site. So we create this in the same way that we did the sites above. Then finally, at the end, we'll need to add all the sites that we've created to our site catalog object, which we do with sc.add sites, and we pass in comma separated list of the sites. Now, after you create each site, you can call sc.add sites and pass in the one site there, or you can add them all at the end. So that's up to you. Then finally, at the end, you will call sc.write, and that will write the YAML representation of this site catalog. And by default, this will go to current working directory / sites.yml. So next we have the transformation catalog. On the left, we have a file tc.txt, which represents the text-based version of a transformation catalog. And then on the right, we have a file generate tc.py, which illustrates how you would generate the same transformation catalog, but using the new Python API. Here in our transformation catalog, we've defined a container and then an executable that will be run inside of this container. So when you create a transformation catalog using the new API, the first thing that you'll do is create a transformation catalog object, and then we will add containers and transformations to that object. So starting with containers, we have this CentOS Pegasus container, so that's the name. It's a Docker container. This is where the image is located. We're going to mount to this directory, and then we're going to set an environment variable in it. So we've set Java home. And so when you do this in the new Python API, you simply create a container object, and we give the container name, CentOS Pegasus. We specify its type, where the image is located, and any mounts, and then we'll set some profiles. Once you've done that, you simply add the container to the transformation catalog object. And then next we'll use this object in our definition of the keg transformation. So here we have keg. So namespace is example, the name of it is keg, and the version is 1.0. In the Python API, you create a transformation object, and then you can pass in those same values here, so name, namespace, version, and we'll specify the site at which this transformation resides, the path to it, whether or not it's stageable. So is stageable equals false means that this transformation is installed at this path on this site here. If this were to be true, that means you could, if it's like a shell script or a Java program or something portable that you could ship around and then run it somewhere else, that's what is stageable equals true would mean. Here we've said container is equal to CentOS container, which refers to this container right here. In the text-based version, you would just give the name that you gave to the container like this. Here we've added some profiles to the transformation, and these are the same profiles that we've added here on the left. So once you've defined your transformation, that's the executable that your job will run, then you can add that transformation to the transformation catalog. And just like the site catalog, once you're done defining everything, then you would call tc.write, at which point this transformation catalog would be written to its default path, which is current working directory / transformations.yml. So next we have our replica catalog. Now this is where you specify the input files that are used in your workflow. On the left we have this file rc.txt, which is the text-based representation of a replica catalog, and then on the right is the same catalog but generated using the Python API. So starting with the first entry here, we have a file that's located at this path on our site local, and it's called f.a. So when you want to add this using the Python API, you simply create a replica catalog object, we'll call it rc, and then we'll call rc.addReplica, and we'll enter in the same items that we have here. So the site, the LFN, just logical file name, and then the path at which this file resides. And then we'll do that for all of our entries, and then in the end, we'll just call rc.write, and then by default, this will get written to current working directory / replicas.yml. So one thing to add here is that with the text-based version, you could have regex type of entries, and you can do the same thing with the Python API. Just check out the docs. There is an rc.add regex replica. Okay, so next we have the abstract workflow. On the left, we have daxgen.py, which is how you would generate your abstract workflow using the DAX3 API. This is our previous API. And then on the right, we have workflow.py, and this uses Pegasus.api, which is our newer Python API. So starting with creating the workflow object itself. Previously, this was called adag. Now you just call workflow, and you pass in the name of this workflow. Next, you want to define some files. So all the files that are passed around between jobs in your workflow, you need to create this file object. And this remains the same as it did before. Next, we want to create some jobs that we can add to this workflow. And the only difference here is that the name of the executable that the job uses is specified by this argument transformation versus name in the previous version. Another thing is that if you define a transformation object, let's say on line 6 or above, just like we did a couple slides ago, defining transformations in the transformation catalog, you can actually pass that object as just a single argument to a job, and we'll pull out namespace, version, transformation name from that object. The next thing is to add some command line arguments that will be passed to the executable when the job is run. So here we've called preprocess.add arguments with camel case like this. Now it's add _ args. And when you pass these in and they get passed to the executable itself, they'll be delimited by a space. Here we've also passed in the file objects that we've defined above. And when you pass those in to add args, we simply pull out the name of the file that's given here. So this fa will be replaced with the string f.a. The next thing is adding inputs and outputs to your job. So previously, when you did this using the DAX3 API, you would call job.uses and you'd pass the file object, and then you would specify a link type. In this case, it would be link.input. In the case of outputs, it would be link.output or link.checkpoint in the case of checkpoints. With the new API, you simply call job.add_inputs, and here you can specify one or more inputs, just separate them by comma. Then when you want to add outputs, you would call job.add_outputs, and you can specify, again, one or more of these file objects. So instead of calling job.uses multiple times and specifying link equal link type.output, you would just call job.addOutputs and pass in a bunch of file objects. Then we have these two flags, and these are the default values. Register_replica equals true, which is what I mentioned in the beginning of the presentation. And so that just means that all of these files associated with this function call here, when the outputs are produced by the job, these outputs will be registered in your output replica catalog. Stageout_ equals true means that these jobs will be sent to your output directory. And then lastly, once you've created the job, add some arguments, inputs, outputs, then you want to add the job to the workflow object. So previously this was camel case add job. Now this is add_jobs, and you can pass in one or more jobs here. Now let's take a look at converting a hierarchical workflow. So again, on the left we have daxgen.py. This is using the old API, dax3, and then on the right we have workflow.py, which is using the new API. So the first thing to notice is that when you create a sub-workflow job, previously we would call this object dax, and you would pass in the file of your abstract workflow description. So in this case it's blackdiamond.dax, and we're passing that to this dax object. In the new API, we would just call sub-workflow, and again you can just pass in the description, the workflow, abstract workflow description, and then there's this argument is_planned equals to false. Typically you'll leave it as false because the file that you're passing in right here has not yet been planned. If it is planned, if it's an executable workflow, then you would set is_planned equals to true. The next thing is to add some arguments to this sub workflow. So previously this was add arguments being camel case, and now it's add_args. And all of these arguments that you pass here are the arguments that will be passed to Pegasus plan when it gets to processing this abstract workflow file. And again, we'll add another sub workflow job, add some arguments, and then finally add those jobs to the whole workflow object. So on the right, we've created these two sub workflow jobs, and they are still regular jobs, and you would call workflow.add_jobs, and you would pass those two in. You can also add them one by one as you go down the script. So here in line 10 and 19, we've added them right after we've created these jobs. In this case, you could call workflow.addJobs blackdiamond workflow and place that on line 9, and then again call this again with just sleep workflow and place it here on line 13, and it would do the same thing. Okay, so next let's talk about adding profiles. So profiles are specific configurations or settings that you assign to certain elements in your workflow, and you can apply profiles to file server, site, container, transformation site, transformation, job, sub-workflow, or the entire workflow. And using the previous dax3 API, this is how you would add a profile to some object. So we're adding a profile here to a job. So one way that you could do that is you would call job.addProfile, and then you'd create a profile object and you pass that to add profile. The other way is to just call job.profile, and then you'd pass in the arguments needed for that profile, which would just be the same things that you pass to this constructor right here. So just two different ways to do the same thing. Now in the new API, we've sort of refactored this a bit, and there's some higher level functions that you can use to add profiles. So the first way is that you can call a job or whatever object to which you can add a profile to, dot add underscore the namespace of the profile underscore profile, and you pass in key value pairs, which specify the keys and the values for those profiles for which you want to add. And you can pass in multiple keys and values. If you want to set multiple Pegasus profiles, you would do it just like this. So the good thing about this is that this ensures that the keys are valid profiles for this namespace. And the nice thing is that if you're using an IDE, you'll get nice autocomplete. You don't have to remember like what a specific profile key is. Your IDE will just pull it up for you because we have these defined in the function definition of add namespace profile for the given namespaces. This works for most keys. However, in some cases, you'll have profile keys that have non-alphanumeric characters in them, such as like a plus or a minus in the beginning, or the N, or a period in the middle. And in that case, you'll need to use our lower level add profiles, which is very similar to what we saw in the previous slide. So you would call job.add underscore profiles, and then specify the namespace. And you can specify key value pairs where the key here will be interpreted as the profile key. But if the key has like a weird, or if it has a non-alphanumeric character in it, then you would do it this second way, where you'd call add underscore profiles, pass in the namespace, and then use this reserve keyword, which is key equals the name of the key and then the value, which is whatever the value is. So in this case, you're adding a profile called plus key name with the value val. So now we can put this all together into one single script. So here we have a script, let's call it workflow.py. And what you want to do in the beginning is first import all of the classes and functions that you need from the Pegasus API. Here we're just doing from pegasus.api import all. And then you'll have some others set up here. So here I've imported logging, and I've set logging its basic configuration and the level to info. And you want to do this if you plan to use any of the Pegasus command line tool wrappers that we have. So if you want to call like workflow.plan or workflow.run, analyze directly from this script, then you should set up logging just like this, and that will expose the logs coming from those underlying tools. Now the next thing is you want to set up a Pegasus.properties file. Like if we have any configuration settings that we want to use that aren't part of the default settings, then you can create a properties file. So here we've created a properties object, call it props, and we've added keys and values to it, and then in the end we call it properties.write, which by default will write Pegasus.properties to our current working directory. So here on the right, I'm just going to show, as we move down in this script, we're going to be writing our properties files and catalogs and the workflow script to which Pegasus plan is going to consume. So next we want to create our Replica Catalog and specify any input files that will be used by our workflow. So here we've created the Replica Catalog object, and we've added a single entry to it, and then we've called rc.write. So this file ends up in our current working directory. Then we want to create a transformation catalog. Here we specify any of the executables that are used by our workflow. And just like with the RC, we call tc.write at the end, and we end up with transformations.yml. Next, we want to build up our abstract workflow. So create some jobs, specify what executables are used by those jobs, add any arguments, inputs, outputs. And then once you do that, then we can directly call workflow.plan and have the workflow be run by Pegasus. So once we call workflow.plan here internally, we're going to write out workflow.yml, which is the default file name for an abstract workflow. On line 39 here, you could manually call workflow.write, but if you don't, it's okay. You can just call plan directly and we'll write it out for you. And so at this point in line 41 on our file system, we have these 4 files, and then Pegasus plan is invoked, and it will consume these files to plan your workflow into an executable one, and then run it if you set submit is equal to true. We also have this function .wait, which will block until your workflow fails or completes, and it'll also print a small progress bar in your terminal window. This wait thing is really good if you're running small workflows, but if you are running like a really long workflow, I'll usually leave it out and just let the workflow run in the background. So now that I've covered migrating to use a new Python API, I want to go over a few useful tips that are good to know as you move forward and convert these workflows to run with Pegasus 5.0. So let's start off with building up the Replica Catalog. So let's say that you have an input directory on your file system and you have all of these txt files in it. And so you're going to need to add these entries to your Replica Catalog if they're all used by the workflow. And so the simple way to do that is you'd create the Replica Catalog object, and using something like pathlib, you can just iterate through the directory and then add all the files that you would need by the workflow. If you need certain files, like let's say there's txt files, JPEG files, and CSV files in here, you could sort of filter them out by just having some kind of if statement here between lines 8 and 9, looking at p.name.ends-with, or something along those lines. And then after you've added all these files to your Replica Catalog, then you would call rc.write, and there you have it, your built up Replica Catalog. Another way that you can do this, and this is sort of a convenience thing that was added before Pegasus 5.0, is that Pegasus plan has this --input dir flag, and you can give it one or more directories for which it will basically do the same thing. It will go through these directories and based on some properties that you set, look for certain files and add them to an input Replica Catalog. Now the next thing is how do you chain jobs together? So let's say you have a workflow, as we do on the right here, where we have a job that creates some outputs followed by another job which uses as inputs all of the outputs of the previous job, and so on and so forth. So this is really easy to do using the Python API. The first thing you do is create the first job, then we'll add a number of output files to this job, then we'll create the next job in the chain, and then here, when we get to adding the inputs that are used by this job, we can simply call job_1.get_outputs, which returns a set of all the output files for job 1, and then we'll put a star in front of it. This is just Python syntax to unpack that iterable into this add inputs function that we have here, and that will simply add all the outputs of the previous job as inputs to the current job. And then again, we'll add some outputs to the current job, and we'll do this same thing for the final job, just like that. Now, one thing to add is that by default, dependencies between jobs are inferred based on input and output files created or used by each job. So what's meant by dependency is that find range, for example, cannot run until preprocess has finished and completed writing all of its output files out. So Pegasus will guarantee that this dependency between these two jobs is upheld, and so it won't run find range before all the outputs from preprocess are done being written. So the last thing that I want to go over with you are some useful resources that you can take a look at as you are migrating your old workflows to run with Pegasus 5, or if you're creating new workflows. So the first thing is to check out our migration notes. So in our documentation, we have a page on how to migrate your workflows from Pegasus 4.9x, or also below, to Pegasus 5.0. And a lot of the content from this presentation is based on what we have in this piece of documentation. So you'll find side-by-side examples just like you did in these slides, and it will show you how to map, like your sites.xml to be generated using the new Python API. The next thing to take a look at is our Python API reference. So we have pretty well documented all of our classes, functions, constants that you'll use in the Python API, and there's also a lot of code examples for the most used classes and functions. The next thing is to check out our Pegasus tutorial. So this is a Docker-based tutorial In this Docker container, we have Pegasus, we have Condor installed, all the dependencies that you need, so you don't need to install anything on your machine except Docker. And the tutorial is self-guided and run through Jupyter Notebook. So you simply just you start up the container, pull up a web interface, and you can start learning how to use Pegasus. But this is also a really good environment to get a feel for using the new Python API. So it's a good sort of like sandbox environment where you can write some sample workflows, see how things work before you get started actually migrating your production workflows. And the last resource is our Pegasus team, of course. So we're always happy to help you get your workflows up and running. You can reach us on Slack. We have this link here. We have a Pegasus support channel in our Pegasus users Slack. So take a look, and we'll be happy to help you out there. So that concludes this presentation, and we'll see you at the next Pegasus Online Office Hours.